So the next thing we want to get into is adding and subtracting rational expressions. So in other words, adding and subtracting fractions. So remember, we have to have what's called like fractions. To have like fractions, we have to have a common denominator. And then all we have to do is add the numerators. So if we look at the first example, 3/8 plus 1/8, that's exactly what we want, is like fractions. So all we have to do is go 3 plus 1, and that gives us this 4/8. But remember, the catch is once you add fractions, you have to reduce. And so notice that 4/8 does have a common divisor of 4 in them, and that does reduce on down to 1/2. So if we look at the next example, 7/12 take away 1/3, notice how we do not have like fractions. So we have to have what's called a common denominator. To find a common denominator, what we need are the denominator has to look the same. So if I look at the 12 as a prime factorization, 12 would be made up of, 2 would go into 12 6 times, 2 would go into 6 3 times, and then 3 would go into 3 1 time. And then as far as 3 goes, the 3 would be just 3 goes in itself 1 time. So remember, 3 is a prime number, so 3 is the only factor of that. So to find the least common multiple, what we need are, we have to have the same factors, but we have to use the least amount possible. So notice that the two different factors are the 2 and the 3. If you look at the 2's, I need 2 2's here. I don't need any 2's there, so I need at least 2 2's. So I need a 2 squared there. As far as 3 goes, I need 1 3 here. I need 1 3 there. So again, I need 1 3 here and 1 3 there. So the most I need in either one of them is just 1. So the LCM becomes then, we need 2 2's and a 3. In other words, that's going to turn that into a 12. So if you look at this problem, 7/12 take away 1/3. Remember, to rename fractions, you're allowed to multiply the numerator and denominator by the same thing. Well, the 7/12 already has a 12, but notice how I got to change that 3 to a 12. And so notice I already have a 2, I already have a 3 there, but I still need 2 2's. In other words, I got to multiply by 4. So if I multiply the denominator by 4, remember, you still got to multiply the numerator by 4 to keep it equivalent. So this turns into 7/12 take away 4/12. And then as we subtract, that gives us this 3/12. But remember, with fractions, you have to reduce to lowest terms. So since we have a common divisor of 3, this turns into 1/4. So that's how this is going to be 5/1 minus 2/3. So again, to have a common denominator, it looks like the first fraction, we would still need to multiply it by 3 to keep the denominators the same. So if I multiply the numerator and denominator by 3, that's going to create a like fraction. So that's going to become then 15/3 subtract then this 2/3. So 15 take away 2 becomes then this 13/3. And typically we would just leave that as an improper fraction. No need to change it to a mixed number. So if we look at D, if we want to add these 3 fractions, notice how the 4 is made up of 2 2's. So as far as my, the 2x is just going to be a 2 and an x. The x is just going to be an x, but the 4 is going to be like 2 times 2. So as far as my least common multiple goes, what you have to identify are the different factors. Well, the only different factors are 2's and x's. So if you look at it, this one, the first, 2x just needs 1x. X just needs an x, and then the other one doesn't even need any x's. So the most that I need is just 1x. So got that. As far as 2 goes, I need 1 2 in the 2x. I don't need any 2's in the x, but the 4 actually needs 2 2's. So the most 2's I need is actually 2. So this turns into a 2 squared. In other words, my least common multiple becomes then this 4x. So what we got to do is pick up on what do I need to do to each fraction to generate that 4x. So notice that the first one, I've already got a 2 and an x, so what I need to do is multiply the denominator by 2 and the numerator by 2. The 3 over x, it needs a 4, so I need to multiply the bottom by 4 and the top by 4 to create that 4x. And the 9 over 4 just needs the x. So if I multiply that by an x, multiply the top by an x, that creates now my common denominator. So this is going to be 10 over 4x plus then 12 over 4x plus then 9x over 4x. So again, dealing with like fractions, we have we got that 9x on the top plus then 22 divided by 4x. And sometimes we may have to factor to see if we can cancel out any like factors. But since 9x plus 22 is not factorable, there is nothing to simplify because we don't want to break that back apart. We want to leave it as a single fraction. So again, to add or subtract rational expressions with unlike denominators, we want to find what's called a least common denominator, or as I said, least common multiple. But since it's on the bottom, least common denominator. We want to rename each fraction so that they are equivalent, but have that new denominator. And then we want to add or subtract the numerators. And remember that denominator stays the same. And then the catch is, in the end, we may have to reduce or simplify if possible. That's our objective. So if we want to add 4 over x plus 3 to 3 over x minus 3, the catch is the denominators have to be the same. So notice how we have two different denominators, an x plus 3 and an x minus 3. To have a least common denominator, we need each one of those factors. So we need an x plus 3 and we need an x minus 3. But the most x plus 3s I need is I just need one x plus 3 is the most I see in either one of them. And I just need one x minus 3 as well. So that becomes my LCD. So what we have to pick up on is, in this problem, we have to multiply the numerator and denominator both by what creates the common denominator. So on the first one, notice that since I already have an x plus 3, I need to multiply that by an x minus 3. But you got to multiply the top by this x minus 3 as well. So when I write it down here, I'm going to actually use parentheses. So that's going to be 4 times x minus 3 over x plus 3 times x minus 3. Let me try that again. Got too many errors in my writing. Where did we go? That thing just took off on us, didn't it? I don't know why it does that, but it did. It took off way up there. There we go. So again, we're going to have this 4 times this quantity x minus 3 on the top here over x plus 3 times x minus 3. Plus then this next fraction, since there's an x plus 3 already there, I'm going to need an x plus 3, but I got to multiply the top and bottom by that x plus 3 is my mental thinking. So that's kind of my mental strategy that I'm just kind of showing there. So that's going to become then 3 times this x plus 3 on the top. And on the bottom, again, we have just this x minus 3 times this x plus 3. So the denominators are the same. So if I keep them in the same order, go ahead and put that x plus 3, x minus 3. This is to make them look like the same order. So again, notice how we have to add the numerators. But to add the numerators, we need to expand out the numerators. So I have to multiply the 4 through and get 4x minus 12. And then expand the 3 through, so it's going to be a plus 3x plus 9. And the denominator is going to stay the same. We'll keep that denominator as x plus 3 times this x minus 3. So then if we combine like terms together, we kind of see that this becomes then 7x minus 3 over x plus 3 times this x minus 3. So notice how the 4x and the 3x are like terms. That's going to give me a 7x. And notice how the negative 12x, I'm sorry, the negative 12 and the 9 are like terms. That's going to give me a negative 3. Now, before you close it down, make sure you can't factor it any. Notice that the numerator is not factorable. There's not a GCF or anything to do there. So we cannot touch that's x minus 3 in the top since there's a 7 there attached with it. So if we look at this next example, we have a subtraction problem. Notice again, to get a common denominator, or LCD, we need to recognize that there's an x minus 2 present in the denominator and there's an x plus 2 present in the denominator. So I have to have both of those factors present. Now, I don't see any more than 1x minus 2, and I don't see any more than 1x plus 4. So that's all I need is an x minus 2 and an x plus 4. So notice how the first one needs that x plus 4. So it's going to turn into x times x plus 4 over x minus 2 times x plus 4. And then we're going to be subtracting, and I got to multiply the second one by the x minus 2. That's going to be 5 times this x minus 2 over this x minus 2 times x plus 4. Now, the catch is with subtraction is the minus sign needs to go through it, the second part as well. So really, yeah, I want to bring the negative 5 through the parentheses when I remove the parentheses. So when I multiply the x times x plus 4, that's just going to be x squared plus 4x. But with the subtraction, the negative 5's got to go through the parentheses. That becomes the negative 5x plus a 10 on the top. And then the bottom stays as is. That's going to be x minus 2 times x plus 4 on the bottom. So the numerator, we should see x squared minus x plus 10 in the top. And on the bottom, we have this x minus 2 times this x plus 4 on the bottom. So notice how we do have a trinomial on the top, but the factors of 10 that give me a negative 1, that's not going to happen. So that's actually prime. So the only thing we're looking to do is leave it like that, or if we want, we can also expand the denominator out as well and change it to like x squared. Let's say it's going to be a 4x and a minus 2x. That's going to be a plus 2x in the middle, minus 8, if we do all that mentally using FOIL. So I can also expand out the bottom, since just kind of make it look a little bit more similar. So that's how we can add and subtract rational expressions.